Welcome back to another video. Hello everyone. Today I'm going to show you a project I built called the Kubernetes Security Scanner. This is a Python tool that automatically identifies security vulnerabilities in Kubernetes clusters. If you are learning about DevOps, cloud security, or Kubernetes, this project demonstrates real-world security practices that companies actually need. Before I dive in, though, let me quickly explain what I will be working with. Kubernetes is the industry standard platform for running containerized applications at scale, right? It's used by companies like Netflix, Google, and thousands of others. But with great power comes great responsibility. A misconfigured Kubernetes cluster can be a massive security risk. That's where this scanner comes in, this scanner that I'm about to show you that I built. It checks your cluster for common security mistakes like containers running at root, overly permissive access controls, and missing network segmentation. So let's go ahead and check this out. This is the project layout. We have our source code and the SRC directory, which contains the main scanner and individual security checkers. We have demo files that show both insecure and secure Kubernetes configurations. I'll be using these to test the scanner. Go ahead and clear this out. I like to keep it non-messy. Let me pull this up a little bit. Okay, so let's start. I already have Docker up and running. Okay, now I'm starting Minikube, which is a local Kubernetes cluster perfect for development and testing. Minikube uses Docker, I already have it open, to run Kubernetes inside a container on my machine. This gives us a full Kubernetes environment without needing cloud resources. What's happening here is Minikube is downloading the Kubernetes image if it's not cached, creating a virtual cluster and starting all the Kubernetes components, the API server, scheduler, controller manager, and more. This usually takes a few minutes, so I'll just give it some time here. Gonna wait, gonna wait. Come on, you can do it. And as soon as this is done, I'm going to verify the cluster. This project here, oh, in the background, I have the architecture file. This took a while to put together, but I like to be extremely thorough. Let me pull this up. Okay, look at it go. It's doing its thing. This is actually the final project of my portfolio. I wouldn't call it an quote unquote official portfolio in the world of professionalism. It's just something that I really wanted to do. Okay. Verifying Kubernetes components. I feel like last time this went a little bit quicker. So what I'll do, oh, I was just getting ready to pause and it is done. Well, that works. So now I'm going to verify this here in just a moment. Before I do though, take a look at VS Code. It's not crazy. I'm using CI continuous integration with this here. All right, let's do this. U-B-E. Okay. Let me verify we are connected. Kube is the command line tool for interacting with Kubernetes. This shows me the API server is running and accessible. Nice. And now we can see our single node called Minikube in a ready status. We now have a working Kubernetes cluster. You see that right there? Minikube, status ready, control plane, bam, done, right? Now I'm going to deploy some intentional vulnerable Kubernetes resources. These represent common security mistakes that happen in real environments. Let me show you one of the problematic configurations. I should have made a quick copy and paste for some of this stuff, but I just have some notes laying around messy, but hopefully I don't mess this up. And secure pod, right? It's pod root.yaml. Okay. Excuse me. So this is the Kubernetes pod definition. So let's take a look at this. If we look right here, check this out. So run as user 0, critical running as root. This pod is configured to run as root inside the container, which is a critical security vulnerability. If an attacker compromises this container, they will have full root privileges, making it much easier to escalate and break out of the container into the host system. Now also, let's see, what else do we have? Run as non-root. Run as non-root false. This is explicitly, or this right here, bam, right in here. This explicitly, right, allows root access instead of enforcing non-root execution. This is exactly the kind of dangerous configuration we want to catch. So now I'm going to do a privileged container. Wow, need to learn how to spell. Okay. So here's another dangerous configuration. Let's take a look at it though. We're looking for, yeah, look at this, privileged true. You see that? Privileged true. A privileged container has almost unlimited access to the host system. It can load kernel modules, access hardware. It can bypass most security restrictions. Now let's take a look at here. Right here, system admin, net admin. Right, these are extremely powerful Linux capabilities that should rarely be needed. System admin especially is dangerous because it allows nearly, well, it allows nearly everything. So now what I want to do is I want to deploy all insecure resources. Geez, I'm a loud typer. Okay. All right. Privilege default. Okay, so yeah, so privilege default unchanged. Okay, did I do this right? So what I did is I'm deploying all of our insecure examples to the cluster. kubectl apply command takes these YAML configuration files and creates the actual resources in Kubernetes. Perfect. So we've just created several insecure pods, a dangerous RBAC role binding that grants admin access to the default service account and namespaces without any network policies. These are all security problems waiting to be exploited, big time. So now what I want to do is I want to verify deployment. Now, stay with me because I know in the past here recently I've done much more visually pleasing, if you will, projects, but I've been wanting to do this for a while because Kubernetes fascinates me. It's very interesting. Did I do it right? Oh yeah. I need to learn how to spell. Well, that's okay. Namespace, default. Try that again. Okay. All right, great. So let's verify our pods are running. We can see insecure nginx root and privileged container. There's insecure nginx root and privileged container. They are both ready. They are both running. Excellent. So now what I want to do, so this is where our security scanner comes in. So this is what we've been waiting for. So I'm gonna go ahead and do it. Okay. Scan, scan, scan. Look at that. So the scanner is now connecting to our Kubernetes cluster using the same API that kubectl uses. It's running 4 different security checkers. First, the pod security checker examines every container for things like running as root, privilege mode, dangerous capabilities, and missing security context. Second, the RBAC checker analyzes role-based access controls to find overly permissive permissions. And third, the network policy checker looks for missing network segmentation. And fourth, the resource limits checker identifies containers without CPU and memory limits, which could enable denial of service attacks. Okay, let's take a look at critical. This is our low issues, medium issues. Here's the high issues, but I don't want that. I want to take a look at this big time. Critical issues. So the first critical issue, container running as root, UID. This is our insecure nginx root pod. The scanner correctly identified that this scanner is running at the root user. Notice how it gives us not just the finding, but also the recommendation, set run as user to a non-zero value and specific remediation steps. Okay. Now let's go through, I don't want to talk too much in the highs, the mediums, or the lows. So I do want to take a look at the summary at the bottom though. You'll see you have a nice, it'll show you how many critical, how many high, how many medium, how many low, security, posture, critical, immediate action required. Oh no. Okay. So that's that. So let's see. You know what I want to do is, okay, so let me say, I'm going to do this. I'm going to save the results to a JSON file so that I can compare them after I fix the issues. Let's do it now. I don't 100% know if this is going to work, but that's okay. If it works, it works. If it doesn't, it doesn't. It was giving me some issues, but we'll see. Namespace default. Did I misspell that? No. Output JSON file before dash fix JSON enter. Okay, so scan complete. Report saved to before dash fix.json. You can see it right over here in VS Code. Excellent. So the scanner can output it in JSON format. So I'm going to take a look at this structure here. I'm going to do cat before fix dot JSON, and then what am I wanting to do here? Whoops, no. Okay. Scan metadata, summary. Okay, look at that. That's pretty cool. Category breakdown, total issues 16. So you can see it includes metadata like the timestamp and scanner version, a summary breakdown by severity, which I think is awesome, and then detailed findings with all the context needed to understand and fix each issue. So I want to attempt to show secure configuration. So let me show you how I can fix these security issues. I've created secure versions of our configurations following Kubernetes security best practices. Let's go ahead and give this a shot. Secure pod, secure. Good old YAML. Enter. Did I screw that up? Okay, so let's see. I want to. So let me take a look at this. What am I looking for? Run as user. Hold on. Oh wow, okay, so run as user 1000. So we are explicitly running as a non-root user. This is a regular user ID with no special privileges. Oh yeah, and then run as non-root true. This enforces that the container cannot run as root, providing defense and depth. That's pretty cool. Okay. Let's go ahead and show the secure RBAC right now. Demo secure proper BAC dot YAML. Let me look at this here. Did I screw it up? I think I got it. Wow, okay. So for RBAC, instead of granting cluster admin, we create custom roles with only the specific permissions needed. This is the principle of least privilege, right? So let's see. Let's take a look at this. Bind the writer role. Okay, interesting. Yeah, let's see. I also created dedicated service accounts for each application instead of using the default service account. This makes it easier to audit and yeah, provides better isolation. I guess this is working a little bit better than I thought. So now what I want to do is clean up the insecure resources and deploy the secure versions. So that's easy. So just do kubectl delete dash f space demo / insecure / bam. So service account default deleted from default namespace. Okay. And then now what I want to do is remove all the vulnerable configurations. Oh wait, it's still working. Getting ahead of myself. I thought about doing like a more animated approach with this, but I thought, no, it's just going to be another terminal project, and I am still learning so much about this. Wow, wasted a lot of hours with this. Let me go ahead and pause this while it's doing its thing. Yeah, because it's taking its time. Oh, just kidding. It is done. Okay, so let's take a look. Just about done. Just about ready to wrap this up. Okay. All right. I think what do I want to do now? What do I want to do? I'm thinking, is there anything else I want to do? Um, Save and compare. C dot scanner. Did I screw that up? No. Space. Was it output? Was that right? JSON file after fix dot JSON. Okay, so let me save the new results and compare them numerically. Interesting. Okay, so okay, good. That's what I wanted to see. Report saved to after fix.json scan complete. Starting Kubernetes security scan, scanning namespace, secure namespace. Oh, it's so cool. I love it. Okay. You know what? What else do I want to do? Show different. Oh, you know what? Um, CI/CD integration. I'm looking at my notes. I don't want this to go on for too much longer. You know what? I think I might just wrap this up. Yeah, I think I might just wrap this up because this isn't the most visually amazing project, but the Kubernetes is incredible and it's something I've been wanting to get into for a while. So I built a Kubernetes security scanner in Python that identifies real security vulnerabilities. The scanner checks for containers, running as root, privilege mode, dangerous capabilities, overly permissive RBAC or RBAC, missing network policies, and missing resource limits. I've demonstrated it on a live Kubernetes cluster, showing how it detected critical security issues in intentionally vulnerable configurations. Then I showed the secure alternatives following Kubernetes best practices and verified that the scanner confirmed the improvements. And yes, I did use GitHub CI/CD. I was going to really dive into that, and I thought, no, this is good enough. This is good enough, I think. Um, yeah, so that's it. That is that is my Kubernetes scanner, and I am loving this. There's a lot more I want to do with this project. There's a lot more I'd like to add, but in all honesty, I don't know if I'm going to or not. I was kind of nerding out with it big time. All in all, it was pretty hard for me to make. I don't know if this is considered to be an easier project or I don't know. I'm still very much learning about it. I've got messy notes laying on my desk here and probably should have did a bit more of a preparation for the video, but it was fun. And I will see you in the next video. Take care.